Hello everyone and welcome to Datazen Talk. We are happy to see you here today with us. Our speaker today is Oleg Litvinov. He is a lead data scientist at EPAM Systems and joining us from Amsterdam. He has worked on many real-world AI projects and will share how he uses Kedro to solve common problems in machine learning workflows. While you're watching, feel free to drop your questions in the chat at any time. We will collect them and cover as many as possible during our QA session after the presentation. So don't be shy, your questions might help others to understand this topic. Also, stay alert. Oleg may ask you some questions during the talk, so be ready to participate in the chat and share your thoughts. So Oleg, now floor is yours.
Thank you very much for having me. I hope everyone can see the slides and can hear me well. Please let me know if something is not clear. But let's begin. I can see the chat with the comments, probably with some delay, but I would be happy to answer the questions or address the concerns as soon as they happen. But let us begin. The topic of today's conversation is streamlining AI projects with Kedro from chaos to clarity. Briefly about me, I'm Oleg Litvinov, a lead data scientist at EPAM Systems, as was already mentioned. And I joined EPAM as intern more than 7 years ago and worked on 11 proper official external projects for EPAM and numerous internal activities. And on projects, I usually take data science and machine learning engineering roles, sometimes with a bit more of applied science, sometimes with a bit more platform engineering. And finally, more important for this talk, I've worked in both delivery teams focused on getting things delivered fast and on platform teams trying to scale best practices, templates, and tooling across many other teams within the company. So I've worked on both sides of the barricade. And this experience gave me a chance to dive into the trade-offs between structure and speed, and this is what we're going to talk about today. So I've introduced myself. Now, please tell me a bit about yourself in the chat. Please type briefly your role, your title, what do you do into the comments so that I can better tailor the message and understand what is the audience. All right, while you're typing the answers, I hope I will be able to see them on the other screen. I will proceed. The agenda is the following. So I will try to make sure my speech fits about 40 minutes, and then we'll switch about like 10, 20 minutes of the QA. This talk is going to be about like moving from chaos to clarity and how Kedro helps to get there. So I will start from some problems which community and I experience on real projects, like mainly it's about reproducibility. Then I will introduce very briefly Kedro as a solution to the problem stated. Finally, we'll talk about rich Kedro's ecosystem and we'll make some conclusions where Kedro is a great choice and when not. And at the end, I will be happy to have a chat with you. And I will also share some materials so that you can study something after our conversation. Yeah, thank you very much for your answers in the chat. I can see them, so I will follow this. So disclaimer, by projects, I mean real production projects, and probably some research or school projects may not need Kedro, but also can benefit from it. For example, I use Kedro even for some internal projects, which I work completely alone on. So Kedro also helps on them. So let's dive into the problems we're going to solve. The main problem from my perspective is reproducibility. So how to make sure that the prod environment will use the same model with the same configuration you trained in the other environment, for example, dev or maybe training environment. Reproducibility is true in the theory, like you want to make sure that you use in production the same things you trained locally, but in practice, this usually fails. So post plus in the chat if you faced this or similar naming in the projects, like train model, train model, final copy, and so on. Double plus if you were a cause for it. I would probably post a triple plus. Maybe you had messages like, hey, what data did you use for training? Or faced some bash scripts to be run before model train or even after train. Maybe you saw people asking, like, where are the artifacts? You were asked if you removed nuns before join or after. What hyperparameters did you use? Like, did you clean the data at all? So I'm sure you faced all these, and who haven't posted plus in the chat are just shy, but I'm sure everyone faced at least one of these. I think the conclusion is sad but obvious. If you cannot guarantee reproducibility of your machine learning processes, you cannot guarantee that you deliver the right value to your customers or users. Users may just get wrong predictions, which causes bad user experience, and you, of course, don't want to have this in your production systems. And even assuming that you're able to find the artifacts, to find the right configs you use for training, for example, the images on the slide are definitely not signals of a healthy machine learning lifecycle, right? There is another problem, especially painful in large companies. It's lack of standardization. And let me show you some examples. Let's look at several projects. So the first one is notebook-centric, which is very likely for example, solo data science projects or maybe some research projects. So you can see here that you have some data cleaning notebook, data like preparation training notebook, deployment notebook. So everything is in the notebooks. This is pretty quick for iteration. You can run experiments pretty fast and explore the data interactively in the notebooks. So we all love notebooks. But of course, you can imagine that this is bad for scaling. So the logic may be split between the notebooks. It's quite hard to test and deploy if you have notebooks. There is no true parameterization and no abstraction. So you just have everything in the notebooks. The other option to consider is the CLI pipeline or scripted pipeline. So this is built like a CLI application with some YAML configs. We have config here, which is great. But this is completely not modular, right? So you have some code split between the files, which is not ideal. And this is difficult to find the entry point. So for example, here you have some bash script like run pipeline, but at the same time, you don't know what will happen after this run pipeline before you study properly the whole content of the repository and the bash script. So no visualization, no entry point, no execution of visualization. So you see everything from the script and you do not interact with your pipeline. You just see the consequences of the run. The final one is the MLOps first repository. So this is usually given to the data scientists from MLEs, which try to follow the best practices. And this is designed for good production reliability. But the experience shows that data scientists get lost in the boilerplate. So you have lots of things here like infrastructure, Airflow DAGs, models, maybe Dockerfile, everything. It's really difficult to experiment and iterate for data scientists. The logic may be buried somewhere between DAGs and source files. So this is very difficult to experiment. So question to you, what do you think is the best? Please write 1, 2, or 3 in the chat. I'm curious about what you think is the most applicable, the best solution for the projects. Yeah, thank you. That's a tricky question because I'm afraid none of this is right. Maybe all of this is right to some extent. But in large companies where people come and leave, people rotate between the teams, it becomes a mess to get acquainted with a project, even when there is documentation. So even if we add some README file to every repository I show, it will be quite difficult to understand, again, where is the entry point, what is the workflow. And even if you are already familiar with the project, you work with it, it's always faster to follow some guardrails and templates for example, some infrastructure. So you know that all your infrastructure exists in one folder. So what is the message here? The lack of standardization slows down development and causes bugs. And this is not good to have all these three together in one company. So it's better to standardize to one template which fits all. I think all the problems may be described by the term reproducibility, but as we're talking about real business problems and real projects, I'd like to highlight transition to prod additionally. So let's talk about the coordination of ML projects during the whole machine learning lifecycle. Usually, 3 engineering groups are involved into data science machine learning projects, like overall we can say AI projects. So the first is the data engineers. They are usually responsible for the ETL pipelines, usually using some large-scale data and tools like Spark, some clusters which are able to process data at scale. Then, based on the data from data engineers, data scientists join and they conduct data analysis, they train models, they produce insights, artifacts. And lastly, based on model artifacts and logic provided by the data scientists, machine learning engineers create optimized inference scripts and deploy models in the predict mode. So usually all these 3 stages are developed sequentially via some contract between them with small temporal and scope overlap. So by the lack of temporal overlap, I mean that, for example, data scientists usually start after some pieces of data are produced, even when there is some contract. So they cannot start their work before the data is prepared. And by the lack of scope overlap, I mean that all these 3 teams, D, MLE, and DS, they are usually quite isolated between each other. And this really causes problems. So the first one is that constant back and forth between the first 2 groups. So please add more columns, change the type here, change the type there. So usually this happens frequently. The data scientists come to data engineers and ask for some adjustments in the data. And similarly, between the DS and MLE, usually questions like, where are the artifacts for feature engineering? How did you transform columns and so on and so forth to make sure that during the inference, the model has the same preprocessing as during the training stage? My personal pain point is that training and inference pipeline do not consist of only model fit and model predict, as you may guess and may imagine. They also have some model-specific preprocessing. So both training pipeline and inference pipeline have some specific preprocessing from raw data coming to an endpoint to the data ready to be put into model. So machine learning models usually cannot work with raw data. They require some preprocessing and some preparation to be done before launching like model fit or model predict. And inconsistency in training and inference preprocessing is very widely happening, and this is a huge problem. You can still use some model registry, and it will help so that you put the model to model registry, and then you use the same model during the inference. But preprocessing logic replication for inference is usually a problem. So this is a huge question, how to make sure you use the same preprocessing during the inference. And Kedro is a framework which solves this and the previously stated problems like reproducibility and standardization. Kedro combines these pipelines into one directly acyclic graph, but gives possibility to work together, like collaborate on the whole pipeline. So about Kedro. Kedro is a framework for production-ready data science. I will try to be relatively high level to concentrate on project and company level problems rather than just code, but of course we'll have to address some technical moments. So at its core, Kedro is built around the idea of nodes, which are pure Python functions that you connect together into pipelines. On the image, you can see a directed acyclic graph represented Kedro pipeline, and it has 3 inputs with database symbols. You can see them like shuttles, reviews, and companies are the inputs for our pipeline. So then there are some nodes which are processing functions with F symbol, like preprocess shuttle nodes, preprocess company nodes, like create some model input table, and so on. So these are like nodes for preprocessing. And in yellow, you can also see some parameters defined for this pipeline. We'll cover them in a bit. So overall, Kedro applies software engineering best practices to machine learning code, including modularity, separation of concerns, versioning, and so on, to make sure you can achieve some reproducibility and other benefits. I do not plan to spend too much time on the exact data science problem using the example because we plan to stay on the high level, but I will give a very brief overview so that my slides make sense to at least some extent. So the project, its future, and the space tourism industry is booming. Globally, thousands of space shuttle companies take tourists to the moon and back. We have been able to source data that lists the services offered in each space shuttle, customer reviews, and company information. So the goal of the project, the data science goal, is we want to construct a model that predicts the price for each trip to the moon and back. So simply, we have three data sources, some information about shuttles, some information about companies and reviews. And there is some machine learning pipeline which predicts some price to the moon and back. This is a very popular project in Kedro's documentation, and we'll follow it for consistency. You can check my more technical and deep tutorial where I work with this project in a more detailed way. But in this presentation, in the current presentation, I'll use the tutorial code associated with the video, but this will be more high level. But now let's look at what Kedro brings and how it addresses the problems we stated. So the first thing you see when you start working with Kedro is the project structure. It is based on the very well-known cookie cutter data science template. There is a link. And you can see that every repository created with Kedro in it will have the following structure. So it has some configuration for all your environments like dev, prod, live, pre-prod, and whatever. We'll cover this more in a bit. So then there is a well-structured data folder for local usage, docs, if exists, notebooks, so that you can experiment and prototype as well, having the things reproducible still. There is a source folder for like the source files and some other things which you can optional add to the Kedro template. Let me show how this looks in the real spaceflight project, which I mentioned in the tutorial. Let me open the code. Please let me know if the code is not visible. I hope it should be. And also let me know if you need some zoom in, but I hope this is visible. I can increase it a bit just in case. All right, so you can see the same folders I have mentioned. So the tutorial contains configuration, data, notebooks, source files. There is also a specific folder for tests. Nothing special on top of every engineer has and works with, but this is a Kedro template which you can follow along the whole company for any project, and this is very helpful to understand like where to look at. An important note that this code is not associated with any EPAM project, so feel free to reuse. The great thing about this structure is that it can be scaffolded automatically, as I have mentioned. So either using Kedro starters or some CI/CD process, Kedro addresses structure and acts as a project template. So when you traverse projects within the organization, between the different units, it becomes clear and simple to find what you need, like where is the data, where is the config. And it's already a big relief, even though we've just started. Like back to Prezel. Now let's see how Kedro addresses reproducibility. So we've talked about the standardization. Let's move to the main part, reproducibility. Kedro registers not only code, like usually we register code, sometimes notebooks together, maybe some parameters like requirements. These are usually pushed to the version control systems. Kedro does something on top of that. It also registers config, which consists of parameters and data catalog, as you can see on the slide. Of course, you can just hard code these parameters right in the scripts and data also in the scripts, but decoupling is more safe, like decoupling code from the configuration. Let's look at these configs in the real project so that this is more interactive. So here is the config I have. In my case, this has 3 folders, so base, dev, and local. Base contains project-specific settings to commit and share with the other users, with the other developers. And local, for example, is the folder, the subfolder, which contains specific configuration for the users and contents not to be shared via Git. For example, these may be some local credentials, data samples. If you do not want to use the whole data set, you can specify some data samples right here. And inside each configuration subfolder, you may find the Kedro data catalog, which is the registry of all data sources that the project can use to manage loading and saving data between the nodes within the pipeline. So we can look at the local catalog. It maps the names like companies, reviews, and shuttles. These are the names of the data set you may remember from the diagram, to the actual files in the system. So in our case, for example, companies is some data sample which I store locally in my repository. So this is just a CSV, and there is an abstraction. You say that this is a Kedro data set, and it can read successfully from CSV, from Excel, whatever really, and this gives you a great abstraction to concentrate on the data sets rather than wait to read them. Dev catalog on the other side also is a catalog, but with a bit different things inside. So let me show you them briefly. It contains the same names. You can see that this is companies, reviews, shuttles, but they are created for another environment, for the dev environment, so that you can read from, for example, Spark dataset while you are running this Kedro pipeline in the dev environment. Or maybe this is a Postgres table, maybe this is a dataset in GCS. So Kedro has multiple connectors to various data sources, and you can parameterize the same kind of entities, logical entities, for different environments. And finally, the base catalog. The base catalog, as I have mentioned, is something to share with the others. And it has the datasets which are created on the fly in any environment. So after we have some shuttles, companies, and so on, we can create on the fly some pre-processed companies, pre-processed shuttles. So these datasets are created during the run of Kedro pipelines, and you can store them in the intermediate tables, in the intermediate datasets to address them later for any purpose. And finally, parameters. Every environment has their own parameters. For example, here I have only one for base because I want to use the same parameters everywhere. And these are very similar to data catalog, but for some purposes like machine learning application. So you say that for machine learning pipeline, I have the following parameters like the size of the test, the list of features I want to use, some parameters for the model I'm going to use, some linear model. So I, for example, can say that fit intercept is true. And you can parameterize lots of things, like you can parameterize separately machine learning pipeline, ETL pipeline. I have it empty, but you can put some ETL parameters here. And you can also have some shared parameters between all the pipelines. So this is extremely helpful, and all these are pushed to Git so that you can see not only code which was executed, but also the parameters. But back to the slides. So on top of the code itself, we also commit config, parameters, and data catalog. And on the next slide, I'll briefly show Kedro's generous connectors to different data sources. So Kedro provides different built-in data sets for numerous file types and file systems, so you don't have to write the logic for reading, writing yourself. And this is achieved using FSPec. And as I shared, you can attach local files, S3, GCS, blob storage, really whatever, many other SQLite databases. But now let's look at the data structure for the local setups. Again, on the top of cookie cutter, Kedro suggests a very thoughtful layered folder structure to store data. So this is used mostly locally, but if you kind of allow, this will be also stored in the remote setup so that you start from some raw immutable data, which you got, for example, from S3 or from some raw data source. You can then produce several intermediate tables, which may be helpful further for example, rerunning from some stage. So what we have in the data, we have some type data when you solve the typing, some domain model data, model features if you make some extensive feature engineering. You also prepare separately model input, and you store models themselves, for example, serialized models like pickled models, maybe neural networks, weights, or so, and so on. And lastly, you have some plots, for example, generated during the pipeline run, and maybe some reports as well. You can see that I have the same in the tutorial. So if we open the data folder, you can see that my raw files locally are the company sample. So this is a reduced data, which I use for local prototyping. And everything here is what I add manually, and everything else is produced during the run. So when I run the Kedro pipeline, it creates the preprocessed companies, some primary tables, models, and so on. Remember, we were talking about a complicated border between data engineers, data scientists, and MLEs. When you use Kedro, all pipelines may be located in the same repository and may be under active development by different teams together. And this is a collaboration rather than isolation as we had previously. So this may be one pipeline or multiple pipelines, which I recommend and which I will show, but united using the same data catalog. So you can see that all the stages of the whole DAG are mentioned in the data log, regardless who is owning them, like data engineers, data scientists, or MLEs. So that all developers groups can work together. Let me show the real example of multiple pipelines united into one DAG. Let me show the Kedro Viz, which is a great tool which Kedro gives to look at your DAG. So I have useful make file, which I use for simplifying the comments. So I will start from the Viz. So this is basically a Kedro plugin, and I'm going to run Kedro Viz. So make Viz. This will open the whole DAG for us. All right. So here is the Viz. I think this is visible to you. Give me a moment, please. I will switch the screen. All right. So you can see the whole DAG created from the pipelines I have locally. So you can see again that we start from the shuttles, companies, reviews, then we pre-process them, store some intermediate tables, so on and so forth. And lastly, we just train the model, which produces a trained model. And finally, we evaluate metrics. We produce the metrics dataset. So everything is registered in the data catalog, and you can see that this is extremely interactive and helpful. So you can see where my data is stored. It is stored in the 01 raw folder, and you can even look at the preview of the data. You can check this out later without me. So this is extremely helpful and interactive. You can also see that I can select the whole DAG, or I can select only one pipeline. For example, this is only the ETL pipeline, which starts from shuttles, reviews, companies, and ends with the primary table. So this is the primary table produced by the pipeline. And this primary table is the start of the machine learning pipeline. So you can see that if we select machine learning pipeline, its beginning is the primary table. So this is kind of separation of concerns, but keeping them together. I will show very briefly how this looks in the code. So you have a folder with pipelines. There is ETL pipeline and machine learning pipeline. And if you look at the, for example, ETL pipeline, you can see that it starts from the pre-processing companies, pre-processing shuttles, and creating the input table. So this is exactly what I was showing on the diagram. So this Kedro Viz is like not just a random tool. This is just an interactive app representing your project as of now. So this can be like auto-updating, so that if you change something in your pipeline, this will be updated here as well. The cool thing about that is that you're always able to relatively simply move nodes from ETL to ML. So for example, let's see, we have the primary table here, and we can say that, for example, since now on, the data engineers will not be only responsible for that, they will be also responsible for the data split. So this means that we just move the border line between the ETL and the ML pipelines while having almost everything the same. We have the same nodes with the same logic. We have almost the same DAG. Like this DAG will be very simple, and you don't have to like learn the project from scratch. So this is extremely helpful to like make some small adjustments. And again, as a reminder, you can zoom in into any part and study in detail. So where is the code? What are the parameters used, like split parameters, which is 0.2. So you can look at the parameters, and this will be an interactive way of exploring your pipeline. You've looked a bit at the pipelines already, and let's now reflect a bit on them and think about the obvious alternative. So the alternative I see is the object-oriented programming. And you have very likely seen this in, for example, scikit-learn source code. You have some base model with like pre-processed training predicting methods. And this base model is inherited by the neural model or another type of model like LGBM. So you take some pieces of the pre-processing, you enrich them with something on top, and then you, for example, rewrite the training procedure. Kedro, on the other side, suggests something inspired by functional programming. So you have some nodes which are executed sequentially. So first pre-processing with some parameters, then training with some parameters like model type. And there is a clear separation between them. I will not dive much into the details why one is better to the other. This is very opinionated. I would just say, for the sake of saving some time, that from my perspective, from my experience, the left one, the OOP, is best for small or independent systems with limited reusability needs. Maybe if your team is from strong software engineering background, or your team is at the very late stage when no major changes are expected, but we all know that this is rarely the case for data science projects. Usually people are less mature with software engineering, and the projects are more on the exploratory phase. While the pipeline-based approach, like for example, Kedro, will be best for scalable production-grade workflows with a need for collaboration and reproducibility. Why? Because really there is some modularity and flexibility with each step. So for example, you can just outsource this pre-processing to some Spark cluster or maybe to some AWS batch or whatever. With the OOP, it's quite complicated to move just one method, for example, pre-processing, to a cluster separately. So you can study this in more details after I share the presentation, but as the conclusion here, the right approach aligns a bit better with modern engineering practices like modularity, testability, scalability, especially for ETL and machine learning projects. So you can test these like nodes as unit testing. While class-based approach can be simpler for small standalone systems, and by the way, this is more Pythonic, but the right one helps really to solve problems we care about in AI projects like reproducibility. I have mentioned the productionization step several times, but decided to move this to a separate slide for clarity. So Kedro helps with deployment on single machine or in the cloud of choice using various services. You can wrap your Kedro pipeline into a Docker container in a couple of clicks and deploy it really wherever you want, like SageMaker, Kubernetes, whatever. So this is very simple, almost out of the box. Kedro itself addresses lots of questions and problems we raised at the beginning, but what makes Kedro shining is a rich ecosystem. Let's look at a couple of plugins. So Kedro MLflow was the game changer for me personally. It integrates seamlessly Kedro and MLflow and allows you to register machine learning experiments in a couple of clicks. Kedro Airflow helps you to generate Airflow DAGs based on Kedro pipelines. So with all the benefits of Airflow, like complex scheduling, detailed management interface, etc., you can again just plug Kedro with Airflow quite easily. Lastly, Kedro Docker we've managed already, so this helps to package and ship your Kedro projects with containers. So these are the most important from my perspective, and they're supported by Kedro developers themselves, but there are lots of community-developed plugins for Kubernetes, SageMaker, Vertex AI, whatever really, and so on. Let's look very briefly at Kedro MLflow as the plugin which helps to address the reproducibility problem from the perspective of the model. I think most of you heard of MLflow. So MLflow is a well-known in the industry a framework aiming to simplify the machine learning workflow, like experiment track and model registry and so on. Let me show you briefly the demo of the Kedro MLflow plugin and how it's integrated with Kedro. So let's move to another terminal folder screen, and I will show you another comment. So this is MLflow, but before that, I would like to show how this is set up very briefly. So there is a plugin which I have already installed in my repository. So when I press Kedro MLflow init, it creates a local config MLflow YAML, and you can see how this looks like. So we'll not dive into the details because this is not needed, but you can see what kind of things you can configure. So you can configure the MLflow server. In my case, this is local, and you can specify some parameters about how you want the experiments and the models to be tracked. So let's return back. Let me visualize the MLflow. So I run the Kedro MLflow UI, and we will be able to see the experiment tracking window. So you can see that this is my Kedro MLflow tutorial, and as soon as I run any pipeline, this will be registered right in the MLflow. So let's go to the file and see I have two commands to run my ETL application and ML application. So let's make run ETL. So you can see that automatically, this is just a command to run Kedro, but it automatically sees that I'm going to use MLflow. So this is automatically captured here. And at the end of my pipeline run, this will be registered in the MLflow. So again, you see that I do nothing except of configuring MLflow. And at the end, this is just registered as an application here. So you can see the parameters, when this was launched, who created this one, and this may be remote. I show this locally, but this may be remote. The parameters, for example, the parameters for the pipeline, I have mentioned that for my ETL pipeline, I need some target column, like my Y, which I'm going to predict. And we can do the same for ML. So when you run machine learning project, machine learning pipeline, this will be also captured by MLflow, and you can see that this is running right now, and now this is done, so machine learning application. And you can see everything I have mentioned here, like features, the list of features which I was talking about in the config. So the list of features is registered here in MLflow beautifully. The test size is here, some parameters for the model, and so on. So if you register some metrics, they will be here, and there will be also artifacts, again, automatically registered by Kedro MLflow plugin. So the model, the pickle files, whatever, everything will be here. So again, almost for free, there is a machine learning MLflow compatibility out of the box for every machine learning need you have. Like there is a way to compare models, you can compare runs, you can version models, you can version experiments, and you can serve right from MLflow. So agnostically to Kedro, you can just take your artifacts and deploy them using just best practices for MLflow. So right now we cannot look at the Kedro, we can just deploy right from here. There is another cosmic feature Kedro MLflow plugin suggests. There is a possibility to register whole pipelines as machine learning model, like as a MLflow model. You remember I was mentioning that register a model to MLflow is relatively a simple task. So putting this artifact to MLflow is quite simple. And this pipeline artifact will be stored in MLflow as an artifact, and this helps to make sure that you use the same model for fitting and predicting. But Kedro MLflow plugin helps you to register the whole thing together as an artifact. So the whole pipeline is stored as an artifact to MLflow together with pre-processing. So right from your raw data until the predictions, there will be some solid artifact. This is just a very high-level example of one Kedro plugin. There are lots of them, so I recommend you to study them separately. Why I like Kedro MLflow? Because it really helps to deploy simpler. So when you deploy, you think only about this artifact. You don't have to think about some additional pre-processing and so on. So this is already in your artifacts. And of course, this helps with the reproducibility. So encapsulating the full pre-processing and business logic within MLflow model ensures that any data transformations applied, like filtering during training and inference, is done in the same way during like training and inference. There are also drawbacks before we come to conclusions. So Kedro's structured approach is powerful, but it is not easy to master, especially for teams used to notebooks. So knowledge transfer can be tough. So if the Kedro expert leaves, for example, some platform team, the rest of the team may struggle. And also keep in mind that not all plugins are as friendly as Kedro MLflow. So generally, every new plugin or integration adds more complexity to manage. For simple or short-lived projects, Kedro structure can be more of a burden rather than of a benefit. So not everywhere Kedro will be useful. Kedro is designed for reproducibility and maintainability, which is a great thing for production, but it slows down the quick experimental prototyping, for example, in notebooks, that many data scientists prefer, especially early in a project. Similarly to the previous point, from my perspective, Kedro's workflow is more aligned with MLE best practices rather than with classic exploratory data science. And data scientists who rely on flexible, interactive work may find Kedro restrictive. And it's not a coincidence that notebook-based development exists and is popular. It's really helpful to have interactive environment with great visualization of every step, like in Jupyter Notebook. You can visualize a lot with Kedro, like in Kedro Viz, you can visualize plots, some graphs, metrics, and so on. But this is not interactive, so this appears only after you run the pipeline. Kedro's reproducibility is only as strong as its weakest link. So if your pipeline depends on external data sources, APIs, or dynamic resources, true reproducibility is hard to guarantee unless you add some tools like DVC to track data versions and some others. And the same for models, by the way. So you see that to track model artifacts, we added Kedro MLflow additionally, and the same will work for Kedro DVC. So it's not out of the box. You can still track like configuration parameters, data catalog with Kedro, but this doesn't address lots of things out of the box. Finally, some will say that Kedro's DAG are not flexible enough. For example, they don't handle conditional branching or dynamic pipeline changes. And for some use cases, this may be not flexible enough. So as a conclusion, Kedro enforces a standardized project structure, making it easier to manage and scale complex AI workflows across company. And this is extremely helpful to make sure that you know where to look at when you join a new project, and you know how to scale every piece of your pipeline, like pre-processing or training. Pre-processing, for example, goes to AWS Batch. Training goes, for example, to AWS SageMaker. This is very helpful. By unifying pipelines, Kedro facilitates seamless collaboration among data engineers, data scientists, and MLEs, reducing frictions and enhancing efficiency. So indeed, if without Kedro, this is more of a pain when all these three parties work separately without collaborating, Kedro makes sure that there is some space for working together. We've talked a lot about reproducibility. Kedro doesn't give you magic, but it gives you some guardrails, version configs, data catalog, clear separation of concerns, but you still have to kind of wire things well together, and Kedro really helps to do that. Be ready to investigate into platform, training, workshops, some learning, because Kedro is not something you can use very easily without specific preparation. And finally, don't use Kedro everywhere when not needed. So Kedro helps to address the problems we mentioned during this speech, but there are some problems like for which Kedro doesn't fit. So lastly, I would like to mention that Kedro has a great open source community, which is happy to help. They have Slack, They have amazing videos on YouTube, like tutorials, so they're extremely helpful and great documentation. So use them, collaborate with people, and probably this will be a great setup for you and your company. This is everything I have. I would be very happy to answer any questions. And later, when you get the presentation, I hope you'll be able to find some useful links, which I share here. That's pretty much.
Yeah, thank you very much, Oleg. Now let's move to questions. Yeah, we have them several. Yeah, question from the chat. I also pasted in our chat. Is
Thank you.
Kedro applicable for AI native cases like prompt versioning, context engineering with RAG, and indexing pipelines for embeddings?
I will look at the question if you don't mind. AI native cases like prompt engineering, context engineering with RAG. Well, Kedro may be sometimes a bit more complex for Gen AI, I would say, because again, all the frameworks are right now in the process of adapting to the new use cases like Gen AI. I would say that partially yes. For example, the combination with Kedro MLflow allows you to use all the new features from MLflow. And MLflow, for example, new versions of MLflow, they allow you to use some, for example, prompt registry and some useful things for your AI native use cases. As for the RAG, I would say it really depends if you really need Kedro MLflow for RAG, because during RAGs you rarely train something. So this is basically about making sure that you connect like the right data, the same data for your augmented generation pipeline. So maybe I would personally start from tools like LangChain and Langsmith for proper management and like guidance over all your prompts and your pipelines. So Kedro may be a bit more tailored for like more classical machine learning problems with some data flow. So this is my high-level answer.
Okay, got it. Thank you. Yeah, now let's move to the next question. Is Kedro compatible with AWS AI services?
Yeah, indeed. Thank you very much for the question. As I have mentioned, Kedro has, like, on top of lots of extensions, Kedro has like native connection to lots of things. For example, I think this answers the question about AWS services like AWS Batch, SageMaker. I have seen some others. So basically, all these third-party plugins, they appear every day, so you can just follow and collaborate in the community and see if there were any others. But for sure, you can process the data in Batch, SageMaker. You can deploy into Kubernetes in AWS, for example.
Yeah, thank you. And do I need to know a lot about software engineering to start using Kedro, or is it beginner friendly for data scientists?
Yeah, it's a great question. I think that Kedro kind of wraps everything for you so that you don't have to think about like proper software engineering terms like separation of concerns, like modularity, unit testing, and so on. Kedro kind of enforces you to use these practices without knowing their names, without knowing a lot about them. So Kedro will make sure you, for example, separate the nodes one from the other to make sure they are kind of easy to manage. I would say this is like an open question. It's way better and way simpler to start with Kedro if you have some software engineering background, and practice shows that data scientists with pure research experience, they sometimes suffer and they sometimes struggle with Kedro. But I would say this is not a limitation if you're a data scientist. So if you're open for these practices, this will be not a big deal to master, to some degree.
Yeah, next question is quite interesting. So if you mean that Kedro like forces you to do things properly and structure a project properly, can I say that Kedro for data scientists is like Maven for Java projects, if you know what I mean?
Yeah, I'm unfortunately not familiar with the Java stack, but answering the first part of the question, Kedro indeed acts like a policeman, so it really doesn't leave you a chance to do things not correctly. And this is always a trade-off. So again, on one hand, you may have some flexibility and rapid prototyping for your data scientists, which can do everything, but they can miss something in terms of configuration and registry. So they produced a great model, but they cannot say you how they did that. On the other side, we have Kedro, which a bit limits flexibility, but this gives you almost like 100% reproducibility. So if some artifact or some result was produced, you can find the way how this was produced. So probably you have some comment on Maven for Java. I'm unfortunately not able to answer this.
Okay, so it's not the topic. Yeah, and is Kedro overkill for small projects or startups with only one data scientist? Or maybe you can even name some criteria or criteria requirements when people should definitely use Kedro.
Thank you for the question. I think indeed for small projects with only one engineer working on them, this is usually an overkill. But for example, for some internal projects I work on alone, I utilize Kedro to make sure I have reproducibility on the first place. So if you want to start the project or maybe rewrite the existing project into a way that you always know where your models come from and how they were trained, and maybe you address these questions once in a month, so you don't work on the project every day, you just come back and forth every month. This is the case when Kedro is very helpful. And another point which may be helpful to keep in mind is further scalability. So if you expect that some other people will come to join your project, and maybe you will scale the nodes separately. For example, you expect that in the future you will stop preprocessing the data locally and you will move the preprocessing to the cloud. Kedro is helpful here when you expect some growth.
So maybe connected to the previous question, does Kedro slow down the process of project start, or development start? So because it can take time to set up everything, maybe instead of it we can already release something.
Yeah, thank you very much for the question. I would say that to really start the project, Kedro is very helpful because it helps you to scaffold the project. So you just run something like Kedro init, or you just create some CI/CD process to establish this structure. And this really saves you several hours, maybe sometimes days within large companies, to understand what kind of structure your new project will have, your new repository will have. So at the very, very beginning, this is helpful because it scaffolds you some template. But later, during the, for example, POC stage or some de-risk stage of the project, Kedro may slow you down because you want to try everything. You want to have some interactive environment like Notebook. And of course, Kedro will not allow you to do everything not registered properly. Kedro will try to make sure you register everything you do. So the very, very, very first stage when you create the project, this is helpful. During the POC, this is questionable. During the later stages, like deployment, maintenance, Kedro is extremely helpful. So I would probably draw this curve of usefulness.
Yeah, thank you. One more question. Can Kedro help in GenAI or LLM pipelines?
I think this is very similar to the question we cited from. Thank you very much for this one. Again, I think due to the usage of, for example, MLflow, which I use actively, this is helpful to register, for example, your prompts. So GenAI works from this perspective. You can register prompts and make sure you know which pipeline used which prompt. But for some other purposes, for example, RAG, I'm not sure Kedro is the best option. So better to consult with the community. Maybe I have not seen these examples, but from my perspective, this is not much to register in terms of training, because again, you do not train much for your RAG. You just want to make sure that you index your database, right? Like for embeddings, for some keyword search. And this is usually something which is done by the third-party vector stores you purchase, like Pinecone, Quadrant, or whatever. So they already make sure that you kind of index properly everything you have, like all the files, when they were indexed for the last time and so on. So this is kind of outsourced of the data of the machine learning pipeline. This is outsourced to the library which manages the data for you. And at the last part, like when you have your augmented generation, the only thing you have is just you paste the data you have from the retrieval, and you have your prompt, and the prompt may be registered in MLflow. Again, maybe better to try LangSmith and LangChain, but again, Kedro MLflow may probably be an answer here.
Okay, thank you. Yeah, and maybe the last question: can you recommend some courses or maybe even certification exams about Kedro? So you mentioned that there are some tutorials, but yeah, it's not like courses. Are there any? Or
Thank you for the question. Yeah. I'm not aware about any courses. I think they do not exist, but what I can recommend for sure is the Kedro webpage. They have lots of information. Secondly, the official Kedro channel on the YouTube, I watch it regularly. They have some great like meetups every week or every other week when they talk about the Kedro's future, about new features. And they also have great tutorials there, like from the very beginning until the very production-ready systems using Kedro. So I would say that this is a full, complete course, which I personally used to begin with Kedro, and now I sometimes consult with some of these videos, like how to deploy here, how to, like, for example, improve the data catalog. So these are the sources I would totally recommend to start with. They're very friendly and very nice.
okay, got it. Yeah, I think that's a wrap our today's session. Thank you very much, Oleg, for the great insights and live demo, and for the showing us how Kedro can really help us in AI projects to make them more organized, reproducible, and scalable. So also, everyone, thank you for your questions, and please don't forget to rate this talk on the event page and give Oleg a thank you badge. Make sure you follow DataZen on YouTube and we're a community platform for future events. And we'll see you next time. Thank you very much.
Thank you very much for having me. Yeah, happy to share.
Bye.
See you all. Bye.